Hey, Josie. So, well, as I told another person asking a question on ScaleAbout, I apologize for the last-minute response. I'm actually sort of off-grid, which kind of you can see here. And I forgot to put a notice about that on my ScaleAbout page, but I guess that makes for a more interesting background. Let's just wait for this boat to pass. Sorry for the noise. Okay, so first of all, great question, and thank you very much for your question. Let me take it up here as well so I can get some of the details. I mean, I'm understanding your question as that you're asking about if you want to get into web development, I guess kind of where should you start, right? Like you were specifically saying software, but I kind of assume that you're asking about like resources, what language, like where to start and how to approach it. So, I mean, this is super difficult because I guess the issue is that whenever you've learned something, your path tends to be different from the path that you're recommending to other people, right? I think this is a phenomena called something, but I can't remember the name. Sorry about my totally messed up. By the way, anyways, it's completely not relevant. So, but the point is that okay, I'll make some recommendations as to what I would do if I would restart. But before I do that, let me just tell you kind of how I ended up where I ended up, right? I think that might actually be a useful way of approaching it. So, I started programming in Flash, actually. So I'm not sure how, I mean, probably you're familiar with Flash, but since it's completely marginalized now, I mean, I understand if you're not familiar with Flash because it's not really relevant anymore. The reason I mention Flash is that it's sort of not at all, I mean, a lot of people would probably not even bother calling it a programming language. It's like, well, I'm a programmer and I write code in Flash, right? Macromedia Flash. It wasn't even Adobe back then, right? And then people would be like, oh, well, that's not a programmer, that's a scripting language or whatnot. I mean, the reason I'm saying that it really doesn't matter what people think, right? Like, if you're using something that you're productive in, that's everything that matters, right? If you can build things that people want to use or that you want to build, that's everything, right? Stick to that, okay? Don't listen to the haters. So I started in Flash, right? And when I started in Flash, I mean, I was pretty young, so me and a friend was sort of building toy games that were stupid and that I mean, hardly even ourselves, like we hardly even wanted to play them because they were so crap. But the reason I'm highlighting that is that I guess that from some perspective, the thing that we learned from that was trial and error, right? So a lot of people tend to say this, right? Like whenever you do programming generally, right? Like not just web development, but programming, it's about learning how to solve problems that you don't know how to solve, right? Which is like many things in life, of course, but like especially with programming, it's like, well, your particular problem has probably not been addressed with every detail exactly the same as within your problem, right? However, if you abstract slightly above the problem that you're solving or trying to solve, there are tons and tons of solutions, right? And I guess it's that sort of thing that we become better and better and better at as programmers as we progress, right? Like we become better and better at realizing that the thing that I'm solving now is called such and such if we abstract it to a larger domain or to a broader if we abstract it to a more general domain, if we generalize the concepts, right? My problem is actually what is known as this problem, or something along those lines, right? and then you can start to Google, and then you can figure out a solution, and then you might even find a solution which is in a completely different language, but you are capable of adapting that solution to the language that you're actually in. But anyways, and that's why I think it's two-sided, right? That's why I think trial and error is important, because somehow you're learning that process as you're trialing and erroring, right? It's like you're facing a very specific problem, and you need to generalize sufficiently in order to be able to find a solution to your problem, because it's very difficult to find the solution if you're Googling for all the specifics, right? Like, no book will write about all the specifics of your case, but they'll write about something which is very similar if you abstract it. So that's sort of, I think, learn while doing trial and error, and that's the reason why trial and error is super duper important when learning to program or to write software. But that's one way of looking at it, right? Looking at the same thing, you could also say that, well, okay, doing theoretical work, right? Or rather, I should say, non-hands-on, non-trial and error work is a very, or let me put it this way: is that thing is, or theory is specifically designed so that we can learn the general concepts without having to go through the pain of finding the path to the generalization ourselves, right? And I mean, that's kind of, I think, why we do theory. That's kind of why we do university, for example. So I'm not sure what situation you are in, and whether you are, for example, in a country that has. So I'm from Sweden, and you can take a student loan and then study at university for free. So if you're in a country that has an arrangement similar to that, I would say it's an unfortunate waste not to take advantage of that opportunity. So if you're interested in programming and want to do web development, I would warmly recommend that you do computer science. So I did actually do information systems, which is actually in the social sciences, but it has some elements of programming, but it's more business studies oriented. But that, I mean, the main reason I did that is because my math grades weren't good enough. If I could redo it, I would read up my math grades and then just do computer science, right? Because the point is, again, you learn the theoretical concepts that you can then concretize down to your actual problem. So I mean, you can approach it from two perspectives, right? We can look at it that way. Like, when you trial and error, when you try to just solve problems on your own, you're sort of doing this bottom-up approach. But when you learn theory, you're sort of doing this top-down approach. You're sort of learning the theory, and then when you end up with a problem, or you find when you, in real life, when trying to build a web application, you find a problem, you need to look at the theory that you know and try to apply it to your actual problem. But when you do it the other way around, when you're trialing and erroring, you're sort of starting with a problem that you're trying to solve, and as you're trying to solve that problem, you sort of abstract out theories that you can use when facing other problems later down the road. And I think both of these parts are super, super important, right? And whenever you take a programming course, I think it's very seldom that they don't recommend that you also actually practice, right? Like, it's usually all the time instructors of programming courses tend to say that, okay, we can only show you some of the stuff, right? But it's super, super important that you actually practice on your own by trying to solve problems on your own. And I guess that's kind of like math in a sense, right? Like, math is very difficult if you just read about it. Like, you have to actually apply it to problems that you haven't seen before in order to sufficiently grasp it, like to actually grasp the concepts in order for them to become tools, right? In some sense, you could think about it that way. It's like, well, you understand the concepts, yes, but you haven't understood the concepts well enough for them to become tools that you can use to solve actual concrete problems. And I guess that's the way we should approach programming as well. Like, yes, we learn the concepts. Like, I mean, if we just start out, right? Like, we learn about functions, and in web development, like requests and responses, and in object orientation, like classes, and in functional programming, like like functors and like all of this stuff. Like we learn about all these theoretical concepts, right? But they aren't really useful until we internalize them and practice them to the point where they turn from just theories into tools. I think something along those lines is probably a good point. But anyways, where was I? Okay, so top down and bottom up, right? So I think you need both of these. Okay, let me try to be a bit more specific, right? We're talking about web development. What would I do? Or actually, I was about to say my path, right? So my path was that I started out doing this sort of Flash programming stuff. At some point, I got into way later, right? Way later. Oh, actually, and then I started dabbling with web development, and I started to sort of read through or sift through sort of online tutorials, copying, pasting a bunch of stuff. This was some time ago, so tutorials were not as good as today, the ones that are on the web, right? And then at some point way later in my life, I started to try to do Flash game development for and make some ad revenue, and I made some very tiny amounts of money from that. And then at that point I realized that, okay, well, it's probably better for me to go and study, and then so that I can do this thing properly and then make proper amounts of money instead of sort of scrap money. And then I went to university to do information systems, and then I started with a bachelor's and then ended up at a master's, and then now I'm actually doing a PhD in information systems. So I sort of got quotation marks stuck in university, but I know tons of people. One of my very close friends actually did a bachelor's for 3 years. Actually, I think he was pre-Bologna. Sorry, this is details, but I think he did 4 years, but he never took out his degree, so he didn't actually finish that thing. But he's, trust me when I say that he's a well-paid, well-skilled programmer, right? He knows what he's doing, right? And so you don't have to do like 10 years of schooling. And also, I mean, he's not the most, he's not the kind of person, actually he's an interesting use case, right? Because he's not the person who spent tons of time in school, right? But I think he spent a sufficient amount of time trying to understand the general things, and he was sufficiently good at generalization in order to see sort of how to connect the dots between different concepts. And then he was keen enough to try things out on his own, like we've been programming a lot together, in order to try to figure out how things work, right? So I guess like that's an interesting point, like curiosity, right? Like if you can foster curiosity in understanding how things work, that's massively important. Right? That's massively useful, right? Like when you're trying to learn something new, if you refuse to give up before you fully understand how it works, I mean, that's how you'll become excellent. Surely, that's like definitely you'll become excellent, because then you'll just spend crazy amounts of time trying to understand it, and when you understand it, you'll be so, like your understanding of that thing will be so good that you'll be able to see how it generalizes across domains. You'll be able to see how the thing that you've just learned is relevant to other things within programming, or even potentially outside of programming. I guess that's the hope, at least. But that's the way I look at it. So, okay, what was I saying? Yeah, but okay, so that's kind of my path, right? At some point during that sort of timeline, I was also working at an advertising agency as a Flash programmer. But what would I say that one should do now, right? I would say something like, okay, first of all, if you have the capacity to enter university and do computer science, I would say definitely do computer science, definitely, okay? If not, I would say read books rather than tutorials on the internet, okay? Tutorials on the internet are great, and do those, but remember that tutorials on the internet usually, unless they're sort of very good ebooks or extraordinarily good tutorials, but I mean, like an insane amount of, or an insane percentage of the tutorials that you found on the internet are very, very practical, right? They are not theoretical. And I think the important point is that you also need the theoretical. So when you're practicing tutorials, you're usually doing practical work, but you also need the theoretical foundation. You also need the theoretical work in order to sort of learn this sort of top-down skill and not just the bottom-up skill. And then I would say read books. I mean, this is pretty silly, but like I was involved in some bachelor education after having finished my master's, and then so I was involved in teaching a database course, and then I was reading the database course literature book, or the course literature, which was a book on relational databases, right? And I was kind of confused. I was like, but wait a minute. In this book, there's actually all the information that you need about relational databases. And I felt so stupid because I was like, well, I was really struggling in this course. And of course, I didn't read the book, right? Like, I mean, I maybe sifted through a few pages in order to try to pass the exam. But if I would have actually, like, page to page read the book, then it would have been a breeze, right? Because the information that you need is actually in the book, expressed in a sufficiently general way so that you can solve all the questions that you would be asked at the exam. And I was like, well, duh. I mean, in some sense, it's so stupid, right? Because it's like, well, that's the reason why you have a book, right? And that's the reason why the book is theoretical, because it's supposed to apply across domains. It's supposed to apply across problems. It's not about just a single problem. It's about showing you how to solve all of the problems that you might face. So that was like a super revelation moment for me. I was like, okay, well, actually, when you have the choice, read a book. Find whichever book is. You don't even have to find the best book, right? You just have to find a book that at least a few people praise for being really, really good, right? I use Goodreads, for example. Goodreads is a good resource for checking out what people say about different books, right? It's like IMDb for books. I don't know, maybe it's not like IMDb. But anyways, and then you can see, I mean, there are tons of software books listed on Goodreads, and then you can see what other programmers say about different programming books. So if you want to get into web development, get a book about web development, right? And of course, I mean, I'm sorry, we didn't talk very... sorry, I accidentally pressed the wrong button. Anyways, if you didn't... What was I about to say? Yeah, sorry, we didn't talk very practically about web development. But I mean, if you are getting into web development, you need to gain some understanding of what the front end is and what the back end is. Probably kind of about networking, right? At some point about asynchronicity. But definitely, I mean, if we try not to make it any more complicated than it is, then the front end and the back end is kind of what you have to gain an understanding of. So I would maybe get a book on web development, just generally, and then maybe try to find a book on HTML, CSS, and JavaScript, right? Maybe not even all of them at the same time. Maybe I would just look for a book on HTML and CSS, or maybe just HTML, and then a book on CSS, and then a book on JavaScript. Probably, for sure, JavaScript, I would look for a book on its own, right? And then remember that when we talk about JavaScript, sometimes people talk about back-end JavaScript, and sometimes they talk about front-end JavaScript. Back-end JavaScript being, for example, Node.js. But I mean, I would probably just, like, instead of going out and buying 1,000 books, try to find a book about web development that people talk positively about, and start with that, right? And start to sift through that, and then work through tutorials on the internet. So again, I mean, I understand that this is sort of the boring answer that one doesn't want, right? Because it's like, well, firstly, of course, you knew that information is in books, right? And probably you didn't want to hear that a suggestion to read a book. But I mean, I'm just probably another guy emphasizing that that's truly a great way of learning it, right? So for example, here's a good example. So in my what's it called? Like in my in my PhD studies now, I'm trying to use Haskell, the functional programming language Haskell in my thesis, right? I don't know Haskell, right? I don't know functional programming, but I'm trying to learn it, and I had some reasons for needing that, but let's not talk about that now. But what I want to say is that so there's this book called Learn UA Haskell, and then there's a book currently being written by, I think it's called Brian Mark, called The Outsider's Guide to Statically Typed Functional Programming. And I'm reading both of these sort of off and on. And as I'm doing that, I'm furiously hacking away and trying to solve problems in Haskell. So I'm trying to solve useful problems that have meaning, that are meaningful to me, right? So I'm trying to actually write the program that I want to write, but I jump back and forth and keep reading these theoretical books, right? These are, okay, you could argue that these are sort of practical books, but what I mean is that they are not practical to the extent that they completely ignore the theory, right? They are non-mathematical, surely, right? Because I mean, there has to be some limit. Like, let me put it that way instead. So, in regards to web development, right? If you want to do web development, I don't think you have to know like every single detail of networking, for example. Like, that's unnecessary. Like, that's too much detail. But you need to have some understanding of how networking works, and you need to have some understanding of the request response model and all of that stuff. So similarly here, right? I mean, as I'm learning Haskell, I need to have some understanding of the math behind it, but I don't need to know every single detail of it, right? I just need to know enough in order to be dangerous, right? Enough to be for it to be useful, I guess is the point, right? So that's kind of how I'm approaching that. I'm doing some of the math, or sorry, some of the top level reading, and some of the top down reading, and some of the bottom up hacking. And I think that's really the way we have to approach it when we learn programming. And there are so many resources on the internet that's another reason why I think having a book is a good starting point, because there's depth to it, right? Like it's long. The book is long, so that means you can keep coming back to that thing, and you can keep working on that thing without running out of things to do, I guess, right? And without losing aim, because the person who wrote the book probably thought about aim, well, okay, it would be useful for people to first learn this thing, and then learn that thing, and then learn this thing, and so forth. So you have some direction. But then again, like, so that's, I guess, maybe how we direct, or how we maintain direction when going top down. But when we go bottom up, you should maintain direction by keeping projects that you work on. So projects in plural, or a project in singular. Like something that you do that has value to you. Like try to build something that you actually want to build and want to finish, right? And if you get tired of one thing and you really don't want to build that thing and you're still learning, just scrap that thing and start building a new thing, right? It's all good. Like the amount of things that I built that I thought would be successful $1 million products that I would like run and sort of take over the internet world with, like, it's ridiculous, right? Like, yeah, I mean, that's not, just thinking about that makes my head explode, because all the amount of hours I've spent programming on products that I designed as real products that never saw the light of day, right? It's ridiculous, but that's also how I learned to do programming, right? By taking the act of programming seriously, and taking the end goal seriously, and trying to build a thing that's actually proper, right? And actually works, and actually has the sufficient amount of detail. That keeps you motivated, right? That keeps you striving towards learning the right things, because you're solving problems that are actually useful problems, because they would help you build an actual application. Okay, sorry. Now I'm now I'm rambling. Anyways, let me try to finish this up. Super great question. Super great question. So again, like in summary, I guess it's like you need some top-down learning and you need some bottom-up learning, and you need both, right? And top-down, I would say pick books, and for bottom-up, for sure, find tutorials or stuff like that, but do find something that you work on and you try to build that you want to build, whether that's a game or a website or a service or an API or whatnot. Like, you'll figure it out. You probably already have something in mind. And then you just keep jumping back and forth between these two levels, but remember to always come back to the theoretical level. Like, I guess what people tend to do too much is to stay too much in the very practical level. Like, the danger of staying too much in the practical level is that you become extremely good at solving problems in the short term. You become an extremely proficient programmer within a specific and narrow paradigm. And as soon as we start to leave that, there's a massive knowledge gap because you haven't understood how it fits into the larger theoretical context. So that's a very dangerous place to be in, I would say. Like, if you think about it from a job perspective, like, that's a dangerous place to be in because it's like you're learning a very specific skill, and if that skill eventually becomes out of fashion or unuseful because it's replaced by something else, suddenly you don't have a job, right? And I don't mean a job in the employed sense, it could be in the self-employed sense, but like, that's the danger of learning something too specific. That's the danger of spending too much time in the bottom up, and that's why you also need the top down. Anyways, those are my 5 cents. Super good, super great question again. Thanks a ton. And thanks for finding the channel. I hope to see you around more on the channel. And yeah, I mean, ping me if you think I thoroughly didn't answer your question or something like that. But otherwise, thanks again, and I'll see you around on the channel.